Bienvenidos, Ushamdi, and welcome to this HUT8 networking tutorial on MPLS Layer 3 VPNs. In this, our 7th and final video of this series, we're going to be covering OSPF as the PE to CE routing protocol. I also want to give a special shout out to Jackson Joseph, who dropped me a really nice note. Very complimentary and greatly appreciated. Definitely some kind words. And so, Jackson, it's viewers like you who make the effort and the time involved in putting together things like this so worth it. So, Jackson Joseph, thank you so much. And let's go ahead and wrap up the director's cut on MPLS Layer 3 VPNs. So, what are we going to be talking about? Well, we're going to be talking about changing customer Z, who's going to become now that problem customer who wants to change their peering protocol from EIGRP. We're going to change it to OSPF. So let's go ahead and get on to the command line. Now, I've done the cleanup on the left-hand side of our diagram. And if we take a quick look back at the diagram, we'll see that the MPLS truck has been backed up over here to router number 5 from our previous video. So over here on the left-hand side, I've already done the cleanup of EIGRP. I cleaned up router 7, but I left something behind here on router 5 that I wanted to show you that comes up from time to time and definitely something you want to be aware of. So, back to the command line. We're going to start on router 2 customer Z. Now, on the customer side, remember, very easy lifting here. And we're also going to talk about a couple of things that we need to be aware of. Now, since CCNA studies, you've probably been told that the OSPF process ID number is irrelevant, that it doesn't matter. And that's true, but it's all about context. In the context of MPLS Layer 3 VPNs, it does make a difference. It's going to dictate whether or not we see the routing information from the other side of the provider cloud as an OE2 routing LSA type 5 or as a type 3, an inner area LSA. And so that's going to be something we want to make sure that we're aware of. So let's set OSPF up here on router 2 for customer Z. So I'm going to say router OSPF, and we're just going to use 99 as our process ID. Now, I'm going to go ahead and set my router ID like we have been doing the whole time here. And then, I could even throw in, passive interface default and then give a no passive interface to gig 02, I think it is. Let's make sure about that before we go too far down the rabbit hole, and it is gig 02. And then let's throw our network statements on here. So 198.51.23.2. And again, we want to lock it down and be as specific as we possibly can. Now the area comes into question here. So do I do area 0? Do I do area 1? Well, remember, and I'm going to drag the drawing tool out here briefly. Remember that when we're talking about MPLS Layer 3 VPNs, that the service provider cloud becomes the MPLS or the OSPF, the super backbone. I'll just say SUPBK, right? So it becomes the super backbone. It's like this huge area 0. So if I've got communications taking place on opposite sides of the cloud, I could say that this is area 1 and that this is area 1. And so that's how we're going to set it up, right? I could say it's area 99 and area 99 because, again, the MPLS provider backbone is going to be sort of this pseudo super backbone area, this mega area 0. So I could use my own area numbers out here just like this. Now, for more complex scenarios, in my INE series, I'm going to be covering all the different permutations that you can go through in terms of what areas setups you could have. Maybe if you've got something hanging back off here, could you have area 0 here between these two guys and then area 1 here? And I'll dive into that in that INE series where obviously there's going to be much more deeper coverage. So here we're just going to go ahead and we're going to say area 1. But remember that that MPLS provider backbone, that is the super backbone. So I'm going to say area 1. All right, and we're going to need a network statement here for 2222, and we're going to lock that down, and we're going to say area 1. And now let's go to the provider edge router, router 3 PE1. And it's here where we had the EIGRP configuration. But remember, we're now saying customer Z's changed his mind. They want to do OSPF, not EIGRP. So that's fine. Now, let's be careful here. Remember, in the provider network, what is the routing protocol that we're using for MPLS in the provider network? Yeah, remember, that was OSPF. Or do show run, sorry about that. And we want section router OSPF. Remember, that's OSPF that we're running, so we have an OSPF configuration. So if I tried to create my VRF instance of OSPF by saying router OSPF1 VRF customer Z, we're going to see an error message here when I hit enter. And it's because OSPF or iOS is smart enough to know that I'm trying to create a virtual routing and forwarding instance with an OSPF process ID that I have already configured. And it comes back up and it says VRF specified does not match existing router. And that can be misleading because maybe I'm looking at that message saying, wait a minute, is iOS telling me that I don't have a VRF customer Z? And that's not it. And again, it's misleading because it says VRF specified does not match existing router, but we know that we have customer Z as a VRF on here because we configured it and we configured EIGRP with it. What it's saying is, hey, you already have router OSPF1 configured. So here's what we're going to do. We're going to say router OSPF, and we'll use process ID 26 because that matches customer Z, Z being the 26th letter of the alphabet, right? So it's something that we can use that's nice and easy. And then we're going to say VRF customer Z. Now here, we are not going to get an error message. Everything's going to work just like it's supposed to. So what are we going to do here? Well, let's go ahead and make sure we set our router ID to 000.3 for, oh, I'm sorry, it's in use by process ID 1, so we'll say 33. And you can see OSPF very picky about how we're doing this. And then let's add our network statement in for the 198.51.23. It would be 3 on the PE router here, and then we'll say area. So if I do area 0, what's going to happen? Remember, the service provider backbone is this pseudo super backbone. So if I say area 0, am I going to get an area mismatch here? Well, let's come back over here to the provider edge router. Ah, perfect, beautiful. You gotta love it when a plan comes together. So you can see, received invalid packet, and we're gonna keep getting that. So we've got the mismatch. Remember, it's the interface that's in the area, right? So by me coming back over here and saying no, and then rerunning that command and putting it in area 1, which is the area that we're supposed to be in, now we go from loading to full. So the backbone behind this interface here, 198.51.23.3, that's going to pretend, right, it's this pseudo area 0. So I can do this because we're going to put the customer in area 1. So the interface on the PE router that interfaces with the customer needs to be in area 1. All right, so we're good here on the PE router with the exception of one task. Remember, when we're dealing with MPLS Layer 3 VPNs, and we've got multi-protocol IBGP, just like with EIGRP, we need to do our redistribution statement. So show run section router BGP. Let's see what we have for that VRF for customer Z. Well, remember, I told you I did some cleanup, but I didn't clean the redistribution statement up. And we'll get to that in a second. And that's why I left config over on router 5 PE2. So let's say router BGP1, address family IPv4, VRF for customer Z, and now we're going to say redistribute the OSPF information from process ID 26, and you'll notice that I could do the metric route map of VRF, so but we want the match, right? Because we want to match internal, we want to match external, and we want to match everything, right? So we're going to match type 1s, type 2s, or external 1s, external 2s, external 1, external 2s, and we're going to match NSSA external. So we're going to match everything we possibly can. NSSA external 2s, right? And so that is what we're matching. So let's take a look and see what we've got here. Do show run section router OSPF. And this is important because that is, sorry, not OSPF, do show run section BGP. It's important because those are the OSPF LSA types that I'm going to be looking to match. So internal, external type 1, external type 2, NSSA external 1, NSSA external 2. We're going to match it all, right? So that's the redistribute statement I'm going to need. And in fact, I'm going to copy this right now because I don't want to have to type that all out again. And now let's come over to the right-hand side of our diagram, and we'll start with router 7 customer Z. Now, we did clean up here. If I say show run section router EIGRP, you'll notice there's no EIGRP section. I cleaned it up. Now, let's go ahead and go into global config here. We're going to say router OSPF, and here on the customer side, I'm just going to say 1. And again, the process ID becomes important when it doesn't match. And you'll see what I'm talking about here in just a second. So let's go ahead and set our router ID to 777, oops, sorry, 0007. And let's go ahead and do passive interface default, and we'll say no passive interface, and I believe it's gig 05. Do show IP interface brief. And it is gig, it's actually gig 06. So we're going to pull back that command there, and we'll say no passive interface default. I'm sorry, passive interface default, no passive interface, gigabit Ethernet 06. And do show run section router OSPF. And let's see what we've got here. I want to make sure that there we go, good. All right, so the network statements that we're going to need, we're going to put a network statement in here for the loopback address, and we're going to put that in area 1. And we're going to do a network statement for the 198.51.57.7. And that's quad zeros, right? To lock it down to be as specific as possible, we'll put it into area 1. And again, on the customer side, that's it. So let's go ahead and save our config here. And now let's jump to the provider edge side, router 5 PE2. So here, if I say show run section router EIGRP, we should have a classic mode EIGRP configuration for the VRF for customer Z, and we do. Now, let's take a look at show run section router BGP. And what we're going to see here is we still have the configuration for the address family for IPv4 VRF customer Z with the redistribute EIGRP statement. Now, watch what happens here. So I'm going to go to clean up and say no router, let's pull that back just a second here, no router EIGRP 65432. So if I say do show run section router EIGRP, do we have an EIGRP stanza anymore? We do not. And let's now take a look at do show run section router OSPF. I'm sorry, I wanted BGP. That's in, we'll see the OSPF again, we know that it's there, but I want BGP to show you that when I removed the EIGRP stanza on the PE router, it auto-magically removes the redistribute statement because iOS is smart enough to know that, hey, if he got rid of the entire EIGRP configuration section, there is nothing left for me to redistribute here on this in this VRF stanza. So it removes that for you, right? So now we're going to go back into router BGP1, address family IPv4 for the VRF for customer Z, and you know what? I highlighted that and we lost that line. And so to make sure that we get the exact same line, I'm going to come back over here. I want this redistribute statement back. And we're going to copy that. And we're going to come back over here. And now we are going to paste that line in, which it is going to take. So now I'm going to say do show run section router BGP. Or does it take that line? It does, right? Even though we haven't configured the OSPF section yet. So now let's go ahead and go router OSPF 26, right? Because process ID 1 is already being used. VRF customer Z. And then I can throw a quick router ID statement in here. Remember, we can't use 5. It's already in use. So we'll say 55. I'll throw a network statement in for the 198.51 and it's going to be 57.5 is my IP, quad zeros, area 1. Remember, I need to match the area number here. So we've got our adjacency up now, right? But are we done? And the answer is probably not. Remember, it's got to be mutual redistribution. So if I were to come over to router 2 customer Z here and say show IP, and say show IP route OSPF, we've got no routing information, right? So what do we need to do here? Well, we're going to have to go back and redistribute on the PE routers from OSPF into EIGRP. So if I say do show run section router BGP, we're good on the BGP side of the house. There's my redistribute OSPF statement. But now we need to go back into that VRF configuration there for router OSPF 26 VRF customer Z. And we need to say redistribute BGP 1, and this is critical. Just like when you redistribute into OSPF, right? We're going to say subnets, right? So we're redistributing from BGP into OSPF. We need that subnet so that we can get variable length subnet mask in LRI in there. So we need that redistribute statement in there. So let's save our config here. We'll come back over to this PE router on the other side, and we'll say router OSPF 26. And actually, I think I'm already in there. Yep, I'm already in there. So we're going to say redistribute BGP1 subnets to make sure that we get subnetted and not just at the classful boundaries in LRI. All right, so we'll save our config here. So now we should be looking pretty good. If we come over to customer Z, let's go ahead and say show IP route OSPF, and we should see some OIA information. Now remember, I talked about the process ID numbers matching on the customer side, and when they match, on the customer side, when they match on both sides of the service provider cloud, we're in good shape, right? What happens when they don't match? And when I mean good shape, we get OIAs, we get inter-area OSPF routing information. Across the service provider cloud, you will never get O routes. You are not going to get OSPF intra-area routes. It's always going to be an inter-area type 3. And there are use cases, and we talk about sham links in the INE series, and what happens when you have a backdoor link and you want to use that instead of the service provider cloud. How can you use the cloud instead of the backdoor link, I should say. So let's go ahead, and I'm going to tear down, and this is going to be really easy to do. We're going to tear down the adjacency and the OSPF config on the service provider side on this side of the equation. And I'm going to change the process ID number so that we can see what happens. So let's get in here, and we're going to say no router OSPF 1, and that's going to tear that down. We'll come to the provider side. I'm going to go into global config. Whoops, we're going to go into global config. We're going to say no router OSPF 26 for VRF customer Z. Now remember, the cleanup in the BGP config should be automatic. So I say do show run, pipe it to section router BGP. That redistribute statement that was in BGP, it's gone. So now let's change the process ID numbers here on both sides, both routers, PE1 and the customer Z router 2. So I'm going to say router OSPF, and we're going to change it to 52. We're going to double the process ID number from what it was before. And we're still going to say VRF customer Z. Now, remember, I've got to set everything back up here again. So we're going to be redistribute BGP1 subnets, and I need my, let's do a router ID statement here, 000 dot, what did we say it was going to be, 33. And then how about a network statement, 198.51.23.3. quad zeros, and this should be enough in area 1. We'll keep it in area 1. And so that's going to be enough. And you can see that the process came up because we already configured things on the opposite side over there on the customer side. So we went from loading to full. Well, what do we need? Well, let's jump into the router BGP1 configuration and go into address family IPv4, for VRF customer Z. And I'm pretty sure we don't have that nice long statement there, but I'm going to steal it from right up here. And we're going to say copy and paste that, and we'll put it in. And now we should be good to go. So if I come out here to the customer side of the house, we've got different process ID numbers everywhere now. So now, what does my show IP route OSPF table show me? It shows me OE2s. And so that's what I was talking about, where the process ID, if it doesn't match, you're going to end up with OE2s, and that may or may not be what you want, right? Maybe you want inter-area instead of external. So if the process IDs don't match on both sides, you're going to get OE2s. So let's take one last look here before we wrap things up. And actually, I'm going to make sure I get it right this time. We'll come all the way over here to Laguna Beach. And over here in Laguna Beach, I'm going to say show IP route OSPF. And we don't see anything here. Give me one second. Did we not configure section router OSPF? Did we not configure things here? So we've got that show IP OSPF neighbor. All right, so time for a little troubleshooting. So we see that we've got the statement there. And let's jump onto the PE router here and make sure that everything show run section router OSPF. Are we good to go here? We've got the VERF configuration. The redistribution statement is correct. And show run section router BGP. Let's make sure the redistribute statement's still in there. And it is. So let me go ahead and say show BGP VPN v4 unicast all. And what do we see? So we see the 7777. You know what I didn't do? I was in such a hurry to get the configuration done that show run section router OSPF. Did I have a network statement for my loopback address? And I did. So where is that going to be? Let's take a look here and say show run. I'll say show BGP VPN v4 unicast all. Let's see if it shows up in here. The 2222, it does not. So show run section router OSPF. Let's make sure that everything looks good there, and it does. And what about show run section router BGP? Did I miss something in the BGP config? And I've got the internal, external. I think I see the issue. And I doubled. So do you see the issue? And and this is what happens when you get into a hurry, right? So the issue is router BGP1, and I did not do this intentionally, but hey, this happens. IPv4 for VRF customer Z. Whoops, customer Z. So I'm going to say no, and we're going to cut and paste this because I'm redistributing OSPF 26. However, what did I change the process ID to? Do show run section router OSPF. What did I change the process ID to? Yeah, I changed it to 52. So I'm not redistributing the right information. So let's get that statement correct. I can probably go ahead and do this. I'll say redistribute OSPF 52, right? We want to make sure we get the right information, and then let's match all the internal, external, and all that great stuff. Now we're good to go. All right, so a little troubleshooting comes into play, and you can see the kind of the logic and the troubleshooting methodology I follow, kind of follow the path, right? Come over here and check and see, okay, am I advertising it? I am. Is the PE router getting it? It's not. So then what could the problem be? Well, it's not getting it as being redistributed. So the problem is I had an issue with my redistribute statement. So we'll save our config there. So now let's come play this out over here over on router 7. Now when I say show IP route OSPF, now we have the OE2 information showing up here. So can I ping over there to the 2222 and source it from my loopback? Absolutely. What if I trace over to the 2222 and source it from my loopback address? Absolutely. And we are seeing that we've got two labels that are being pushed or imposed onto the label stack. Or this is the label stack, right? So let's get into the provider cloud. And this is going to be kind of our last hurrah here. So now when I say show BGP, VPN, v4, unicast all, I'm going to get a whole bunch of information, right? Because remember, I'm seeing some BGP information from customer A. And so if I wanted to trim that down, I could say for the 2222.32, right? And again, we have these BGP extended community attributes for OSPF. And this really gets into the weeds here in terms of what these numbers represent. And hexadecimal wise, we're using 52, and 52 is represented in here somewhere. I think it may be the 34. So again, we'll go into deeper detail in the INE course. But again, you see we want to make sure that it's kind of transparent, that the MPLS cloud is kind of transparent. So we have to send over the OSPF routing information along with the VPN v4 advertisement. And here's how we do it. We use BGP extended communities, right? So I see my next hop is 3333. And what do we see here? We see 3003. And that is going to be the VPN, or I should say the VPN label, right? That's going to dictate VPN membership when this information gets over to router 3. So if I go to router 3, PE1, and I say, show MPLS forwarding table, and what label did we have over there? Well, we know the label that's going to be over there. It's going to be 3003 because we're talking about the 2222/32, and that's what that V in there means. It means it's a VPN label. And there's no label here for outgoing because it's going to be an IP packet. We're sending it to the CE. But when it gets to the PE router, after penultimate hot popping is going to happen on router 4, and the transport label comes out, it arrives here at router 3 as an MPLS packet. Router 3 looks into the MPLS forwarding table and says, hey, local label 3003, that's me. And it's a VPN label. So it knows the VPN, the VRF to which this traffic belongs. It takes that label off because the only reason that label's on there is to dictate and to signal VPN membership for the VPN context. And it's going to forward that traffic along. So let's go ahead and do this. We'll kind of walk through one last time, right? It can't hurt to do it one last time. And I've already forgotten the other number. It's 3003. And what did we have? 4,000? Where are we at here? Where is that information? I thought we had it up just a second ago. And am I looking right at it and I don't see it? That's okay. So I'm going to say show, and we're going to say BGP, VPN v4, unicast, all for the 2222/32, which I think I just did. But I saw the... And I'm actually drawing a blank right now as to where I just saw. How about show IP... Ceph for, and this should show for Ceph for, is this going to show me? I think this will show me what I'm looking for. I'm trying to get it to show me 2222/32. There we go. That's what I'm looking for. Sorry about that. I was drawing a blank there. All right. So here's my VPN label, the bottom label. We've got a local label, doesn't come into play here, right? And then we've got the transport label to get us over to router 4. So show MPLS forwarding table. Right? Let's do this packet walk here. You can see that if I'm going to the 3333, which is the next hop for traffic trying to get to the 2222, I'm going to use the outbound because there's that local label of 5,000 that we saw right here, right? But we need the MPLS outgoing label to push on top of the VPN label to get us to the 3333 so that the VPN label can then be evaluated to determine VPN membership. So all I wanted here was my numbers, 4,000 and 3,003, and there they are. So one last time, back to the drawing. My VPN label is 3003. My MPLS transport guy for MPLS trucking is 4,000, right? So those are my labels. So here we go. Traffic comes in from router 7. and it comes into the PE router. It shows up in that VRF where the route distinguisher gets prepended. Now we've got a VPN v4 prefix. We're going to go ahead and we're going to assign, when we look up where is that traffic going to go, we know that the traffic is going to go to PE1, router 3. The next hop is 3333. So what does router 5 PE2 do? He's got a VPN membership label that he's going to assign because he learned it from router 3. So he throws that on there for the 2222. Let me straighten that out a little bit there. I just moved the drawing. Sorry about that. He's going to put that on there for the 2222 that he learned from router 3 as a VPN v4 prefix. So he's got his VPN membership label. And then he says, great, well, now I've got to get to the 3333. So I'm going to look at my MPLS forwarding table. I know that MPLS is required here. So what do I need to get to the next hop? Well, he knows that the outgoing label to get to that 3333 is 4,000. So let's take this to its completion. Little sound effect, right? Truck pulls into router 4. Router 4 looks at 4,000. And let's take a look at the P router, router 4. He's going to look at his forwarding table for MPLS, and he's going to say, hey, something just showed up here with a driver that says, hey, I'm label 4,000. What do you want me to do? And we're going to tell the driver, hey, you need to get out of the truck. We're popping you out of there. Penultimate hop popping is coming into play now. So we're going to take the driver out of there, and we're going to shove it out our gig 03 interface to the next hop. So let's do that. We get rid of the driver. It's on autopilot, right? It's one of those Tesla trucks. And now he shows up over here because he knows he goes out that interface. He shows up here at router 3. Router 3 says, hey, you're coming in here as an MPLS packet. I'm looking at the only MPLS label you've got, and it's 3003. So we've already seen this. Let's take one last look at it on the provider. He says, yep, my local label 3003, that's what you're packing in there for the VPN label. I know that's a VPN label, so I'm going to send you out as an IP packet, and you're going to go out to customer Z router 2. And that's the MPLS packet walk. We did it for both EIGRP and OSPF. So hopefully that makes sense, right? I sort of love the truck, right? Because it's MPLS Transport Company. You got the transport label, who's my driver. He's going to take us as far as he can. And then when the truck pulls into the final destination, we're looking at that VPN label. That is what matters. All right. Well, that is going to wrap up the 7-part series here where we broke it down. I tried to keep the videos a little shorter than normal so that they're a little more digestible and you can dig in and find what you're looking for a little easier. I can't thank you guys enough. Again, big shout out to Jackson Joseph and a shout out to all of you guys for putting me over 1 million views. It's greatly appreciated. I hope you enjoy this series. I feel like it's far more polished and well done than that series I did 4 years ago, right? Again, thank you so much. You guys have a great weekend. This wraps up this Director's Cut series, and I will see you in the next series. And hey, here's to the next 1 million views.